Okay, the questions we didn't get to today that were from homework the last time I saw you before today, or yesterday, or whatever day you're watching this. Anyway, page 553, number 9. An alpha particle has a mass of approximately, so it's giving us the mass, 6.6 times 10 to the negative 27 kilograms, and bears a double elementary positive charge. So that means Q is 2 times 1.602 to the negative 19 coulombs. Such a particle is observed to move through a 2 Tesla magnetic field. So B is equal to 2 Teslas along a path of radius 15 meters. So, or I think it's 0.15 meters. So part A wants to know what's its speed. So we know R is equal to mv over qb. So that means V is equal to RQB over M. So R was 0.15 meters, Q 3.204 to the negative 19 coulombs, B 2 Teslas, divided by 6.6 to the negative 27 kilograms. Forgot to dig out my answer, so I'm going to have to type this in. So 0.30 times 3.204 to the negative 19 divided by 6.6 to the negative 27. And you should get I'm just checking my answer here. 1.456. 1.456, maybe 4 if you want another digit, times 10 to the 7th meters per second for A. B says, what is its kinetic energy? So from grade 11 physics, we would know kinetic energy is equal to 1/2 the mass times the velocity squared. So 1/2 mass, 6.6 times 10 to the negative 27 kilograms, and the velocity that you just found, 1.4564 to the positive 7 meters per second squared. So you have this speed in your calculator. Don't clear it, just square it. That way you're keeping all the digits. Times half of 6.6 is 3.3 to the 27 negative. And you should get, if you don't round, 6.99938, etc., times 10 to the negative 13. And energy is measured in joules. I don't think I screwed up. Did I remember to square that? Yeah, I think I did. I'm just looking at the answer in the book, and either they round it or, because theirs is fairly different from mine. Not like it's 7.4 instead of 6.99. Anyway, C, what potential difference would be required to give it this kinetic energy? So potential difference V is equal to work over charge. And another way we can write this is it's equal to EQ over Q. So we just found, or E of any kind, in this case EK, kinetic energy over Q. So we just found the kinetic energy, 6.99938 times 10 to the negative 13 joules. And our charge was 3.204 to the negative 19 coulombs. So taking my answer, dividing by 3.204 to the negative 19, we get a voltage of 2.1845 to the 6th volts. Okay? That's number 9. Now number 9 walked you through the steps that connects R equals mv over qb to kinetic energy into voltage. Coming up, they're not going to do that. They're just going to give you the stuff and ask you, because they could have asked you right off the top, what is the voltage? Could have found the speed, found the kinetic energy, and then the voltage. So number 10, a 3 to the negative 2 Tesla magnetic field. So 3 times 10 to the negative 2 Tesla. Magnetic field has a mass spectrometer, causes an isotope of sodium to move in a circular path with radius r is equal to 0.81 meters. If the ions have a single positive charge, so Q is 1.602 to the negative 19. A single positive charge means a single elementary charge, and are moving with the speed of 1 times 10 to the fourth. V is equal to 1 times 10 to the fourth meters per second. What is the mass? This is just one step. I was expecting more. Now, just before we do this question, to translate it, an isotope is just, maybe you already know it, but it's any given element on the periodic table has the same number of protons in all of its molecules, but not necessarily the same number of neutrons. Okay, and so an isotope means it has a different number of neutrons, but the same number of protons. If the protons changed, it would be a different element. But the neutrons can change, leaving it as the same element, and we'll come back to this when we get to nuclear, so don't stress about it now. But I do love the way your textbook just mentions it, like you should learn it. You should already know it, but you only learn it in a couple of chapters from now, a couple of units from now. And a mass spectrometer is a spinny thing that they have that separates the particles that are, like if you have a sample and you don't know what the particles are, you put it in this thing that spins it. And as it spins it, the ones with more mass move further out, and the ones with less mass stay in the center, so it separates them by mass. Okay, so there's the translation of the question, but really all of it wants to know is what is the M. So R equals mv over qb. So M is going to equal rqb over v. R 0.081 meters, Q 1.602 to the negative 19 coulombs, B 3 to the negative 2 Teslas, and the speed 1 times 10 to the fourth meters per second. Type this in. So 0.081 times 1.602 to the negative 19 times 3 to the, was it 2 or 3? 2, and then divide by 1 to the fourth. And you should get 3.89286 to the negative 26 kilograms. Okay? Number 10. Number 11. An alpha particle, which is a doubly ionized helium atom, so it means Q is going to be 2 times 1.602, or 3.204, to the negative 19 coulombs, has a mass of, gotta love the fact that they used a helium alpha particle in question 9, and they told you the mass was 1.66, and in question 11 they tell you the mass is 1.67 times 10 to the negative 27 kilograms. Clearly the alpha particle put on mass since we did it. It's accelerated by a voltage of 1000 volts, 1 kilovolt, in a uniform magnetic field where B is 6.5 times 10 to the negative 2 Teslas. What will be the particle's radius of curvature? R is equal to. So this V is a capital, it's voltage. Our R equation is R equals mv over qb. This V is a small v, it's speed. Even if you make this V on voltage tiny, you still can't sub it in there, the units will not work. So you need to go, the question wants R, but you cannot get it right away. You need to go to V. So we know that V, voltage, is equal to E over Q, or W over Q. In this case, it'll be equal to kinetic energy when you're doing a spectrometer. So 1/2 mv squared over Q. So we could find